In this video, you will learn various information about stars and their formation. I hope you like it. Stars are one of the most important and fundamental astronomical objects in the universe. A star is formed from clouds of gas and plasma that come together under its own gravitational pull. It generates light and heat through nuclear fusion reactions that occur in its core. Stars are the building blocks of the observable universe and make up the majority of galaxies. Here is detailed information about the formation, structure, and evolution of stars. 1. Formation of stars. The formation of stars begins with the collapse of a large gas and dust cloud, a molecular cloud or dark nebula. Let's examine this process in more detail. A. Molecular clouds. Stars are born from cold and dense molecular clouds. These clouds are composed of elements like hydrogen and helium and are often referred to as nebulae. A molecular cloud can span several light years in diameter and may take millions of years to undergo the collapse process. B. Start of collapse. The gas within the cloud begins to collapse under its own gravitational pull. As the center of the cloud becomes more dense, the temperature and pressure rise. Once this collapse begins, most of the cloud's mass is drawn toward the center, where a protostar forms, Sa-C. Protostars are extremely hot and bright before nuclear fusion begins in their cores, but nuclear energy has not yet been triggered. During this stage, the temperature at the core of the protostar can reach around 100,000 Kelvin, and its outer layers are typically very inflated. The life of a protostar lasts until nuclear fusion begins in its core and the star reaches a stable state, which can take a few million years. Nuclear fusion and the birth of a star. A star begins to produce energy when hydrogen atoms in its core fuse to form helium atoms. This marks the beginning of the star's main sequence phase, where the temperature and pressure inside the core increase and the star reaches equilibrium. The balance between gravitational pull and outward pressure allows the star to enter the main sequence stage. 2. Structure of stars. A star is composed of several layers, each of which has a distinct function. These layers, from the inside to the outside, are as follows. A. Core. At the center of a star, nuclear fusion takes place. This region is extremely hot and under high pressure. The core is the source of all the star's energy production. The core can reach millions of degrees in temperature. B. Radiative zone. Surrounding the core, energy is transported mostly by radiation. In this region, photons lose energy as they pass through the star's inner layers, making it highly dense. C. Convective zone. Outside the radiative zone, energy is transported by convection. Hot gas rises, and as it cools, it sinks, creating convection currents. This zone is more prominent in larger, cooler stars. E. Surface. The outermost layer of a star is where light and energy are emitted. The temperature of the surface typically ranges from around 5,500 degrees Celsius to 6,000 degrees Celsius, as in the case of the Sun. Classification of stars are classified based on their brightness, color, temperature, and size. The most common classification system is the Harvard Spectral Classification, which divides stars into 7 main categories. O-type, the hottest and blue stars; B-type, A-type, F-type, G-type, like our Sun; K-type, M-type, the coolest and red stars. Stars are also classified based on their luminosity. I, supergiants tuned, giants, third main sequence. Stars, fifth main sequence stars, like the Sun. Fourth evolution of stars. Stars undergo an evolutionary process from birth to death, which depends on their mass. This process typically includes the following stages. A. Main sequence. Stars spend the majority of their lives in the main sequence phase. During this phase, they produce energy through the fusion of hydrogen into helium in their cores. A star like the Sun will spend about 10 billion years in this phase. Red giant phase. When a star exhausts its hydrogen fuel, the core begins to collapse and the outer layers expand. This transition marks the star's entry into the red giant phase. The outer layers cool, and the star becomes red and much brighter. C. Final stages. The final stages depend on the star's mass. Sun-like stars. These stars will begin helium fusion in their cores, but eventually exhaust their helium fuel and transform into a white dwarf. Massive stars. Massive stars undergo a supernova explosion at the end of their lives. The core undergoes intense nuclear fusion, releasing vast amounts of energy. After the explosion, the core may collapse into a neutron star or, if the star is massive enough, into a black hole. 5. The life cycle of stars. A star's life cycle spans its entire existence, from birth to death. Smaller and medium-sized stars live much longer, while massive stars burn through their fuel much faster and have shorter lifespans. The remnants of stars, after their death, contribute to the formation of new stars, planets, and other astronomical objects in the universe. Conclusion: stars are not only sources of light, but also massive furnaces that generate the elements necessary for the formation of planets and life. Their evolution plays a crucial role in shaping the universe, and the knowledge gained from studying stars forms the foundation of astronomical research. That's all for the video. Don't forget to like and subscribe. See you soon.